right, we're going to go ahead and get started with reviewing adding, subtracting, and multiplying polynomials. What expression does this set of algebra tiles represent? So basically, they want you to collect all the like terms. So how many blue boxes of x squared do we have? 10 of them. So you're going to write 10x squared. All right, that's collecting like terms. And then over here, we have how many tiles of 1? So plus 5. All right. What is, how many terms does this thing have? 2 terms, right? Yes? All right, what's the degree? The degree is 2, right, for the exponent? What's the constant? And the constant is 5. Quick review, and how would I name this? Binomial. So it's a quadratic binomial. All right, so for number 2, how many x squares do we have? Okay, so 5x squared. Now, these are red. All of these are negative x, right? How many of those do you have? 8 or 9? Yeah, 8. So minus 8x, because it's negative, right? And these are negative 1s. How many negative 1s do you have? So what do I write? Plus 6 or minus 6? Huh? Minus 6, correct. Okay. What's the degree of this polynomial? 2. Degree 2. Degree is the highest exponent. And is this quadratic, linear, or a constant? Choice. Quadratic, linear, or a constant? How would you call this? We call it quadratic, right? And how many terms do you have? How do you call something with 3 terms? Trinomial, all right? So what am I doing? I'm reviewing, clear? Because this term right here has the highest degree. The degree is to the exponent. So when you look at this right here, hold on, let me make sure the width of the pencil here. All right, so this exponent is 2, so that makes this degree 2. This right here is an understood 1, so that makes this term degree 1. And this is a constant, so it's going to be degree 0. So which term has the highest degree? That one. So that determines the degree of the whole thing. Okay. Another question? All right, this one. Now what this is an exercise. They're taking this problem right here, right? And we're going to use algebra tiles to solve it. Did I skip one? No, right? Yes or no? Okay. And what this is a subtraction. So we're trying to subtract 2 blue blocks from the original problem. Y'all there? So if I remove a block, right, then we have to cancel the block that we removed. If I remove another blue block, then I need to cancel the other blue block that I'm removing. Now, if I take away a single x, then I need to take it away from here from my original problem, right? Because that's what it's subtracting is. I'm removing stuff. And over here it says 3 single ones. So it's going to be I remove 3 single ones. It don't matter which ones, as long as you remove 3. All right, so now that we've removed everything we wanted to remove, what's left over? How many x squared tiles are left over? How many x tiles are left over? 20? Yes, plus 9x. Why aren't you taking notes? Oh, you are? Okay, plus 9x, because we have 9 x's. And how many constants do we have left over? So plus 1. All right, let's see another question. What's the leading coefficient? The leading coefficient is 4. Why? Because it's the coefficient on the term with the highest degree. Yes, 9 is also a coefficient, but that's a linear term. In this case, we want the coefficient of the quadratic term. Right? And so this is a quadratic trinomial again. Leading coefficient, the boss of the boss. All right, same thing, it's an exercise. This problem has been translated into algebra tiles, okay? Subtracting means that you're removing. So if you want to subtract 5 green ones, we're taking away 5 green ones from here. Now we want to subtract 6 ones, okay? So what's left from the original problem after you subtract those tiles away? Write it down. All right, see if you get it right. The worst that's going to happen is you'll make a mistake, but then you'll find out if you did, okay? So how many negative x squared tiles do we have? So this is going to be negative 8x squares. Right? We have 8 of them, negative x squares. How many x tiles do you have? A single one, right? So plus x. That's this green one right here. And how many 1 tiles do we have left? So what do I write? Plus 3. All right. Think about it. Does it make sense? Yeah? All right, so now we're going to do the exercises, but we're going to do them without the tiles, okay? All of these problems coordinate with what you have to do in IXL, okay? They all come from the IXL assignments. Now, this is addition. When it's addition, we don't have to worry about it, okay? We can just combine like terms. So most of you do well when it comes to addition. It's when it comes to the subtraction part that we have the issues, okay? So it seems that 2 is the highest degree, right? How many quadratic terms do we have? Is there another term that is quadratic? Yes or no? Louder. No. All right, so you only have a negative 5b squared. How many linear terms do we have? Which ones are linear? Which one is a linear one? Give me an example of a linear term. 3b is linear, so I'm going to put a box to differentiate. What's another term that's linear? Negative 9b. Okay. So now either mentally or in your calculators, what's 3 plus a negative 9? Negative 6b. Now notice that I'm calling them quadratic terms, linear terms, and I'm going to talk about the constant terms. Which ones are the constants? And what's negative 3 plus negative 9? Let's see if you were paying attention. What's the leading coefficient? Exactly. It's negative 5 because it's on the term with the highest degree. But what do we notice in number 6? It's no longer addition, it's subtraction of those 2 terms. So on the test, some of you guys kept on asking me, give me a hint, give me a hint. And I said, distribute the negative sign. and it was like, what? It didn't mean anything. So if that was you, pay attention and make it mean something. This is what distributing the negative sign means. What's a negative times 4x squared? What's a negative sign times a 2x? And what's a negative times a positive 7? That's it. That's it. That's what distributing the negative sign means. That's what I was asking you to do. Okay, so now if you want, you can rewrite those first 3 terms, but I don't feel like rewriting them. Are we clear? All right, so now out of the terms that are left over, right, the 6 of them that are left over, which ones are quadratic? 5x squared. We're going to put a heart on it this time. And what's the other one? Exactly. And we're going to put a heart on this one. All right, I kind of messed up my negative sign, so I'm going to try again. Look at that. All right, so what's 5x squared plus a negative 4x squared? Exactly, 1x squared or just x squared. Okay, that's 5 minus 4, 1, okay? Which ones are linear terms? Okay. And what do you get when you combine a 2x and a negative 2x? 0, right? They cancel, they're a 0 pair. They have opposite signs, so they cross out. And now the constants, what's 9 and a negative 7? So there you go, all that work for this. All right, let's see if you were paying attention. What's the leading coefficient? What's the definition of a coefficient? Number in front, right? And how is an x a number? It's not. X is a variable, right? So what is the leading coefficient? No, the degree is 2. What's the leading coefficient? 1. If I wanted to name this polynomial, how would I name it? Using the degree and using the terms. Is it quadratic, linear, constant, exponential? What is it? It's a quadratic binomial. Quadratic because of the x squared. Binomial because I have 2 terms. Clear? All right. All right, so let's see if you were paying attention. What are we going to do with this negative sign? Distribute it. All right, so negative 6w squared minus 2. Now, I don't feel like rewriting all those 4 terms. Clear? So now, which term should we start out with? Which one has the highest degree? Which one? Yes, 4w cubed. Is there another one that has a w raised to the 3rd power? No, so that's the only one there. Okay. Is there another quadratic term? You're very quick with your integers. Okay, save some for the others, okay? All right, so what's 9w squared minus 6w squared? Not negative 3, the 9 is positive, so it's going to be positive 3w squared. Okay. Do we all agree? Linear terms. Is there another one? So you see why we end up with just 2w? Because that's the only term, okay? There's nothing to combine it with. And then a little box for my constants. I have a 3 and I have a -2. So plus 1. Ooh, lordy lord, I gotta name this. What's the degree? 3. So it's gonna be cubic. How many terms?
4.
Polynomial. And that's the leading coefficient, LC. Cubic because of the degree, it's degree 3. Polynomial because it has 4 or more terms, okay? We're good? All right, any question on adding and subtracting? All right, an easy one. Perimeter, what do I do? Add. Thank you. We add them, okay? Write it nice and big. Capital A, capital D, capital D. Add. All right, how many U terms do you have? So I have U plus U plus U is 3U. What is 9 plus 9 plus 3? 7? Is it? You sure? Do y'all need to go to your book bags for your lunch? All right, so from now on, get used to having your lunch with you for this section so that you can just walk out and you don't have to waste time over here, okay? All right, go get your lunch and then, let's see. All right, so let's start getting used to keeping our lunch with us, okay? All right, I think we're back in business. All right, so did you guys find the perimeter for the next one? All right, very quickly, how long do you think it should take to find the perimeter for this one? Answer. How long does it take to find the perimeter for this triangle? Tylik? Does that mean we're all done or what? Are we good? All right, take this opportunity. Answer it, answer it. So you just gotta combine all the terms that have 10W, 9W, and 7W, and that was how much? 21? 26? You guys are correct, 26W. And -8 and -5. That's it. So if somebody wants the perimeter, there you go. Difficulty level. Difficulty level. None, right? All right. Can you all do the answer for the last one as well? So, whom should I call on? You made eye contact. Nick. Yeah, combine like terms. Keep going. Well, first of all, which ones are the like terms? The 5A here and the 5A there. So what's 5A plus 5A? 10A. Are there any more A's? Maybe on the other sides. You got to add those two A's. So how many A's do you have in total? 12A. Now looking at the constants, you have an 8 here, a 6, an 8, and a 6. So how many do you have in total? Plus 28? All right, there you go. So that's the perimeter. All right, let's move on to multiplication. All right, finding the product. Here's the one thing that I told you guys. Adding variables versus multiplying variables. You ready? Okay. Why are you on your phone? Thank you. All right, so if you have x plus x, that's going to give you 2x. Notice that the exponents don't change. Clear? It's when you have x times x that you get x squared. Clear? So we're going to be multiplying now. So we need to add the exponents. Same base, add the exponents. Any questions on that difference right here? All right, so get in the groove. We're going to be multiplying now. When we multiply, we talk about the distributive property. That means we multiply into things. The 7 is going to get multiplied by the -4. What is 7 times -4? And then v squared. That one doesn't change because we're not multiplying it against anything. All right, and then you have to multiply the 7 with the other term, which is also another 7. So what is 7 times 7? So there you go. These are not like terms. So this is the final answer. All right, we're using the same concept here. Now we're going to have 4t times -t squared. So start with the coefficients. What is 4 times a -1? Louder. -4. And now you have, you see this single t? What's the exponent on the single t? On this one is 1, right? On this one is 2. So what is t times t squared? T to the third. You have to add the exponents, 1 plus 2. Now we need to multiply this times this. What's 4t times 3? Was that one person that I heard that she was very confident about her answer? Does anybody else have a question or a concern? We're about to do multiple of these. I'd like to start hearing you answer some of these questions, okay? If not, I'll just have to get some volunteers. Oh, we have to distribute this 3 times because we have 3 terms. All right, so now multiply and write down the answer for those 2. I want you to write it down. The worst that's going to happen is you're going to be wrong and you'll just have to scratch it out, okay? But start putting yourself on the line. What is 3x squared times -3x squared times? Just write it down. Did y'all have a moment to think? All right, what is 3 times a -3? -9, excellent. And what is x squared times x squared? Add the exponents. X to the 4th. Cube is a 3, okay? All right, 2 plus 2 is going to give you a 4. We're good? Everybody survived that one? All right, so now take 3x squared and multiply it by the middle term, which is just x. Write it down. All right, so it's going to become what? 3x squared times x becomes? What are we multiplying the 3 times? 3 times 1 is 3, and then we have x squared and x. What would you say was the exponent on x? 3 as well, right? Because there's 2 and there's 1 here. 2 plus 1 is 3. And don't forget the last term. We got to take 3x squared and multiply it by negative 2. 3 times negative 2 is going to become negative 6. And then we got to carry the x squared. Yeah? All right, we're going to find out when you start doing the assignment. All right, information about these tiles. This is the area, okay? The length and the width go here. And we multiply the length times the width to get the area. So what do we have to multiply to get x squared? Well, that means that the length has to be x, and this one also has to be x, because what is x times x? X squared, right? The area is x, so how do we get x? You get x by doing this distance here is 1, and this longer distance is x. What is x times 1? X. That's why the area is x. Same thing with this one. This is 1, and that one is x. 1 times x gives us an area of x. Now, what gives us an area of 1? 1 times 1. So that means that the length is 1 and the width is 1. I'm going to break this down to you. But honestly, I'm not a big fan of algebra tiles. I know, I just thought like the biggest crime for math teachers. But, algebra tiles. But here we go. Write a multiplication expression that does this area model represents. So what you have to multiply by to get all of these tiles is what it's asking. All right, you see this one right here, this side of this rectangle? We're not going to use this one. Why? Because it's got blue tiles. Okay? You see this top portion right here of the rectangle? We're not going to use it. Why? Because it's got blue tiles. All right, but you see this side right here? Do you see any blue tiles? So we're going to use this one, right? And I already told you about dimensions. The longer side of the green bar is x. Clear? This is also another longer side. All of the sides on the ones are going to be ones. Now add this up. What is x plus x? All right, so this is 2x plus 3. Where did the 3 come from? All right, so that's this distance right here, okay? Length or width or whatever you want to call it. Now let's do this bottom part right here. Once again, we're faced with the longer side of the green bar. Clear? The longer side of the green bar happens to be x. So we have an x here, x, x, and these distances are 1 each. Okay? So how do I write this expression? 3x plus 3. And this is what you have to multiply to get this answer. Lost it. I'm sorry. So what is the expression? The expression is going to be 3x plus 3 times 2x plus 3. And it goes back to what I just told you about the dimensions of your squares, okay? Which we wrote them down over here on this block. Right? When you're looking at this rectangular one, the longer side is going to be x, and the shorter side is going to be 1. All right. All right, so are we using this side? Why not? Because it's got blue. Are we using this side? Why not? Got blue. So we're going to use this one and that one. All right. How long is this green one? Christopher, how long is the green one? The short side of that one is 1. This is the longer side. So how much is it? X. And all of these are 1s all around, right? So how do I write this? All right. We're going to do the same thing here. All right, what is the length of the longer side of this green one? X, and all of the sides of these ones are 1. So this is x plus 1. So this one is x plus 3 times x plus 1. Just make sure that you review that, okay? Oh, Lord, what was I thinking? All right, so now determine this distance. And then that one. And then fill in the answer. How many x's you got going now? And how many 3's? How many 1's? So x plus 3 is 3x plus 3, right? Did you agree? All right, how many x's going down? Sweets, how do I write that? Write it as 3x. And what's this distance? 3. All right, now over here, how do we express this distance? X plus 3. All right, so I just went around and kind of make sure that you were working on it. And we agreed on the board that this one was going to be 3x plus 3, and this was going to be x plus 3. Look at the rectangle. This is the longer side. The short side is over here. So that would be a 1. This one is x. If you look, I gave you 2 green ones over here. One is standing and the other one is lying down flat, okay? So this we'll consider 1 and this we'll consider x. The distance, okay? This distance is 1 and this distance is x. If I want the area, though, I only need length and a width. X times 1 gives me x, which is why they have an x in the middle. All right, did y'all figure out the last one? Oh, no, this is a different question. They don't want the multiplication expression, okay? They already gave us the multiplication expression. All right? The multiplication expression is here. How many x's do we have? So 2x plus 1. Do we agree? See? What about this one over here? How many x's do we have? So 2x plus 1 as well, right? And they want to know what it is when we multiply those. What is the area? Well, let's count. How many blue ones do we get? Right? So the answer is going to be 4x squared. How many x bars do we get? 4, so plus 4x in a single one. It's like they already did the work for you, okay? They just want you to multiply. All right, start finding the answer for the next one. They already gave you the expression. They want to know what is the answer when we multiply. Well, count your bars. Let's go. I know y'all can count bars. You don't need me to count bars. Let's go. Count the tiles. George. What do you say, George? You want to share the answer with me? How many x squares do you have, George? You see 3 blocks. 1, 2, 3, 4, 5. That's it. You only see 5? How many? 9. Do y'all agree with George? Yes, it's 9x squared, okay? Now, how many x bars do we have, or x tiles? George was supposed to be counting them. Do you agree it's 12, or are they tricking you? Okay, so plus 12x. And how many tiles of 1 do you have? So plus 3. Everybody okay? Did anybody need help with the counting? We're good? All right, time to get to the... All right, so what about when we don't have tiles? Real life, you ready? I'm going to teach you foiling. First, outer, inner, last. Basically the distributive property, which I already taught you, but here we go. All right, 3w plus 2. We're going to start with the 3w. Put a dot on top of it. And we're going to multiply it with the first one over here. So what's 3w times w? All right, this is the first one. Don't write it small. Write it nice and big and clear so you have a perfect example on this stuff. So this is going to give you 3w squared. Right? Now that we've multiplied that, now we're going to take the 3w and we're going to multiply it with the 2. What is 3w times 2? So 3w times 2 is going to give you 6w. All right, now if I keep on drawing, I'm done with the 3w, right? Now I need to distribute this positive 2. But if I draw more arrows here, it gets complicated. So in math, what they do is they draw the arrows underneath the 2. So put your dot. And we're going to multiply with the w first. What is 2 times w? So I'm going to write it over here. We did 2 times w. That's how we're getting this 2w, okay? And then the last one, we take the 2 and we're going to multiply with that 2. What is 2 times 2? That's where we get this plus 4 from. All right, what is 6w plus 2w? All right, so your final answer is going to be 3w squared plus 8w plus 4. Do you guys want me to continue writing this middle step? Or go straight to the multiplication? Stay straight to the multiplication? Good. So let's try it here. Which one are we going to start off with? Where are we going to put the first dot? Participate. Let's go. On top of the 2c. All right, so you got to multiply it with this one. What is 2c times 3c? 2 times 3? C times C? Louder. C times C. Why is it only 2 people answering? Everybody, C times C. Okay, good. Are you sure we all know this? Okay. Next, you're still in the 2c, but now you got to multiply it with the next term. So that's a 2. So what is 2c times 2? So plus 4c. All right, now we're going to put the dot underneath which number? -3. So -3 is going to get multiplied with 3c. What is negative 3 times 3c? Negative 9c. All right, last multiplication. Negative 3 times a positive 2. Negative 6. Now, combining your terms right here. Okay. Yeah, so it's going to be 6c squared minus 5c and then minus 6. I need you to learn how to do this quickly. Are we clear? Yes? Am I asking for too much? Good. Thank you for being reasonable, my students. Let's try it again. Quicker. Let's go. 3. I hate z as a variable. Do you hate z as a variable? That and q. Because when you write it, if you don't curve the bottom, it looks like a 9. All right, what is 3z times 3z? 9z squared. Multiply 3z times 4 plus 12z. All right, where are we going to put the next dot underneath which number? Negative 4. All right, so what is negative 4 times 3z? Negative 12z. And lastly, negative 4 times positive 4. So now this one said what? A special case? Why was this one a special case? What does that say right here? Opposite sides. You see how you have a 3z and a 3z? A 4 and a 4, but what was different? This is negative and this one was? All right, so now let's continue. Do we agree that this is? They cancel out. When you have the same terms and opposite signs, your middle terms are going to cancel out. All right, so what's the final answer? All right, a perfect square. Yes? All right, the next one, let's go. What's 3y times 3y? What's 3y times negative 1? What is 1 times 3y? And what is 1 times negative 1? Once again, it's another special case where you have the same terms, opposite sign. And look, yes, the middle terms end up canceling. One is positive and one is negative. So your final answer is going to be 9y squared minus 1. I want no cheating with online calculators for this stuff. I need you to be able to multiply polynomials. Okay? All right, this one, what does this mean? What do I do here? This is what you do. This is another special case. When you have this, you're going to go t plus 3. T is another variable that I don't like as a variable because it looks like a plus sign, you know? Squared is when you multiply something by itself. So this means t plus 3 times t plus 3. Write it down. Let's go, let's go. And now we do what we were doing. We distribute. All right, what's t times t? Oh, wait, I need to change the font size on this thing. And what's t times 3? Plus 3t. Keep going. This one times this one. Plus another 3t. And then the last one is 3 times 3. Now, in this case, we have the same terms with the same signs. They're both positive signs, okay? So what happens to the middle? Do they cancel out? No, they don't, right? So your final answer is t squared plus 6t plus 9. Yes? All right, if I need to multiply this, how are we going to rewrite it? Minus 2 times put work on top of your desktop. So you can stay awake. So it's 2b minus 2, right? This is what you're doing. All right, distribute. And after you're done distributing, you're going to switch with your partner and you're going to check each other's work, okay? Negative 4b. All right, let's see what other color. Purple. Here we go. Or blue, I'm not sure. All right, did you do this one? Negative 2 times 2b. Jaden? What did you get? All right. All right, then lastly, did you do negative 2 times negative 2? What you get? Let's see if you don't mess up on the signs. Negative 2 times negative 2. Positive 4. Negative times negative is going to give you positive. And then once again, the middles are like terms. And no, they don't cancel because they have the same sign. Are we clear? They only cancel when they have opposite signs. So your answer is going to be 4b squared minus 8b plus 4. How'd you do? You did it right? Did you get it right? Not completely? You got halfway done? You can answer. All right, everybody's favorite model. All right, this is the 3y. That's the 3y here, see? This is the y plus 6. Here is the y and the 6, clear? So what is 3y times y? 3y squared. Faster, people, faster. What is 3y times 6? 3 times 6. All right, so it's 18y. And so are these two like terms? Why not? Exponents are different. Excellent. What's the final answer when we multiply this? We're going to get 3y squared plus 18y. All right. Fill in the white boxes. Let's go. This is the 2x minus 4 is here. And the negative x plus 5 is there. All right, please multiply. Let's take this less than a minute to get all 4 products. All right, fight the sleepiness. I know we just came back from lunch. And it also reviews, so it doesn't help, okay? Many of you already got this. All right, what is 2x times negative x? Or wait, should I send somebody up to the board? Did you say you were going to volunteer, Blessing? All right, what's 2x times 5? Let me see, what's negative 4 times negative x? Nobody knows? 4x? I don't think that's right, 4x. Right? Is it right or no? It is correct. And what's negative 4 times 5? 20. All right. Are any of these terms like terms? Okay. So that would be this one and that one, right? So the answer when we multiply this is going to be negative 2x squared. Anybody, somebody, what's 4x plus 10x? Plus 14x minus 20. This is really easy, right? You're like, what was I struggling with last year? I don't know. This one, find the area. This is a parallelogram. Hold on, I misspelled that. Did I? I did not, right? Parallelogram. I did not. I was on the right track. And the area is going to be base times height, or essentially length times width, okay? It comes down to the same thing. The base here happens to be, all right, I'm giving you the hint right there. The base here is 9. And what's the height? All right, so now multiply. What is the area? Multiply. What's the area? Louder, honey, I can't hear you. There we go. It's true though.